Welcome! This video shows how to download a registration module, how to execute it in multiprocessing, and how to visualize longitudinal data. MP3 allows to easily create your own modules, but we already provide more than 50 modules on a Git repository. To download a module, just click on the MP3 user modules repository and choose the wanted one. Here, I chose a registration module that uses an algorithm of the well-known neuroimaging toolbox, SPM. One just needs to download the file and paste it as a MATLAB file in this specific folder of the MP3 source code. Once it's done, one can launch the pipeline manager and immediately access to the module. We are now going to load the pipeline designed in the former video and add this new module at the end of the pipeline. This module, which is one of the most complex MP3 modules available, registers a source image on a reference image and applies the computer transformation on others selected images. Let's select the first input, the reference image. There are several ways to select the first input that influence the behavior of the module. If I select a sequence name, the registration will be intra-subject and intra-time point. If I select a sequence and a time point name, the registration will be intra-subject but inter-time point. Eventually, selecting a sequence, a time point, and a subject names will compute a registration inter-patients and inter-time points. Here, since I selected a sequence and a time point names, it means that for each subject, I will register images from all time points to the one I selected. As a second input, I selected the same sequence name as the reference image, the sequence T2. The registration will then be better and easier. As third input, I chose to select the region of interest representing the tumor and drawn in another MP3 video. To summarize, this module will register the T2 images from all time points of a patient on the T2 image of its first time point, and the same transformation will be applied on the region of interest representing the tumor. After adding the module to my former pipeline, I can save this new version of my pipeline. Since the registration is time-consuming, one can execute the pipeline on several cores thanks to a multiprocessing pipeline execution system called PSOM. P-S-O-M. Since the module applied on the whole database created 5 jobs, I execute the pipeline on 5 cores and chose to remove the jobs already executed in a former execution. The MATLAB command window once again displays regularly the details of the execution. When the pipeline is finished, one can observe the resulting scans by using the longitudinal mode able to display scans through the time points of a subject. Here, I open the scan before the registration. One can see that they are not in the same referential. Now, after the registration, the scans are in the same referential and one can observe the growth of the tumor. Since I applied the computer transformation on the region of interest representing the tumor, one can open those files on the registered scans and display a parametric response map analysis that gives us graphical information about the evolution of the selected voxels through time. Thanks for watching. See you in the next video to improve your MP3 utilization.